in order to graph this quadratic equation, we're going to do several things. But the first thing that we're going to do is find the vertex. And to find the vertex, we use the formula negative b over 2a. That is our x-coordinate of our vertex. And to find the y-coordinate, we plug that back into our function. And this is the function notation for that. Anytime you plug something into a function, the function notation looks like this. It's f of whatever that you're plugging back in instead of x. So, we got to figure out what b and a, where those come from. They come from the same place that they do when we look at our quadratic equation. So, this quadratic function that we have right here is not in descending order. So I'm going to rewrite it so that it's in descending order so I can figure out what A, B, and C are. Because when it's not in order, it makes it a little more difficult to figure that out. So f of x is equal to, I'm going to put the x squared first because that's the largest exponent that I have. So I've got negative x squared. Always keep the sign with your term. The next term will be the x term, and that's a positive 10x. And then we have our constant, which doesn't have an x at all, and that's the negative 16. So a is the coefficient of the x squared term, which in this case is negative 1. B is the coefficient of our x term, which in this case is 10. And if we needed it, c is our constant, which is the negative 16. But it's not in our vertex formula, so we really don't need it right now. You might want to write down what c is equal to in case you can't factor this one. If we can factor it, that's going to give us our x-intercepts, and that will be easier. But if you can't factor it, then you can always use your quadratic formula to find out what your x-intercepts will be. So negative b, in this case, that's negative 10, because 10 is b, over 2a, and a is negative 1. So what I have is negative 10 divided by negative 2, which is just a positive 5. That's part of our vertex. That's the first coordinate. That's the x-coordinate of our vertex. So vertex is a point, so we need a y to go with that, or else we don't know where the point goes. To find that, we just plug that back into our function. So instead of x, I'm going to replace it with a 5 and find out what y equals there. So I have negative, and I'm putting in a 5 instead of an x. So negative 5 squared plus 10 times 5 minus 16. So I'm going to evaluate this, and that'll tell me what the y-coordinate is. So that's negative 5 squared, which is 25, plus 10 times 5, or 50, minus 16, which gives us negative 25 and positive 50 will give me a positive 25, and then minus 16. I do mine step at a time. If you can do those all together, that's fine. And that equals 9. So that is our y-coordinate. Because remember, we could write y equals instead of f of x equals. They mean the same thing. So 9 is the y part of our vertex. And that's what we have graphed up here. We go to the right 5 and up 9. There's our vertex. Now we need another point in order to graph it. Because on my math lab, the graphing tool lets you select the parabola. And the first thing that you graph is the vertex. But then you need some other point. So we're going to find our x-intercepts. And that's finding the zeros of your function. So if we set this equal to 0, the easiest thing to do to solve is to factor if you can. Remember, we could either factor, we can use our quadratic formula, we can complete the square if necessary. You've got options for this. And personally, I like to factor if I can. Now this negative in front of my x squared, that throws me a little bit when I'm trying to factor. But since I have an equation now, it's 0 is equal to this, I can factor out a negative. And that's what I'm going to do. I'm going to take out a negative. So what that does, if you factor out a negative, is changes all the signs. So that makes that a negative 10x and a positive 16. So if that is supposed to equal 0, then if I factor what I have in parentheses here, one of those factors would have to equal 0. So I'll set up my two sets of parentheses, and I know I need x's to get x squared. And since the last term is plus 16, I know that the signs will be the same. And if I look at the center term, I've got negative 10x, so my x term is negative. If the signs are the same, the negative in the middle tells me they're both going to be negative. So I'm factoring 16. What are the factors of 16 that add up to a negative 10? That's going to be a negative 8 times a negative 2 will give me a positive 16, but a negative 8 plus a negative 2 will give me a negative 10 for the center, for the middle term rather. So that is the way this one factors. So now I just have to set each of those factors equal to 0 to see what my x-intercepts are. So x minus 8 equals 0, or x minus 2 would equal 0. And if I solve each of these, just by adding to both sides of the equation, I get that x is 2 or x is 8. And if so you can use either one of those points to graph it. And here they are on our x-axis, x at 2. I can't hit it very well with my pen, but anyway, and the x is 8. Those are where our parabola crosses our x-axis. Here's a closer up picture of the graph of the parabola, and I did neglect to mention that since this one is a negative x squared, our function is negative x squared plus 10x minus 16, that the negative in front of the x squared means that it's going to open up downward. But you would see that when you graphed your vertex and either of the x-intercepts. It has to open up downwards. But that's what lets you know that it's going to do that ahead of time. The last things that we're supposed to find for this problem is the axis of symmetry, which after you have your vertex is very nice. It's very easy to find. Axis of symmetry is this vertical line here, so that on either side of our parabola, it's symmetrical. That's where it gets its name, axis of symmetry. And the way that we find it, it's always x equals, because vertical lines are always x equals, and it's the x-coordinate of our vertex, and we've already found that. That was 5. X equals 5. That was the very first thing that we did after we rearranged it so that it was in descending order. So if you have your vertex, you already have your axis of symmetry. Now for our domain and our range. Your domain is how wide is, if you think about the graph, how wide is this graph? What's the leftmost point that it goes to? What's the rightmost point? And if we extended this graph, it keeps going down in this direction. Mine's a little bit wider. And keeps going in this direction. It keeps getting wider and wider and wider. Another way to think of it is what type of numbers can we put into our function? That's also another way to think of domain. There are no restrictions on this one because it doesn't have a square root and it doesn't have any fractions with x on as the denominator, so there's nothing that we can't use for an x. So our domain is any real number, so negative infinity to positive infinity. That's our domain. Or in other words, this thing keeps getting wider and wider and wider forever and ever. So that's the domain. The range is what type of numbers do we get out of it. And those come from our y-axis. So what's the lowest number that we can have? Well, this one keeps going down and down and down forever. So negative infinity is the lowest that it goes. What's the highest number that it has? That's the other number for our range. Well, this one does have a topmost point. It stops right up here. And that number was the other part of our vertex. We had y coordinate from our vertex, and that was 9. And it actually stops there. And so we have a bracket for that one because it actually does touch at 9. And that's how you find your range. I hope this is helpful. Just email me if you have any more questions, or let me know if this works for you.